Last episode, you put many agents under one supervisor, one graph, many subgraphs, but they took turns. Sometimes you don't want turns, you want the same job done on 5 things at once, then folded back into one answer. That's MapReduce, and LangGraph spells it with one primitive, send. Fan one task into n workers, fan their results into one reduce node, and keep it reproducible. Here's the shape. A split node looks at the input and emits not one edge but a list, 1 cent per item, 5 chunks, 5 arrows leaving the same node at the same time. That list is the fan out. The runtime reads it and schedules 5 worker invocations. Each worker is the same node, run once per payload in parallel. Worker 0 gets chunk 0, worker 1 gets chunk 1, and so on. Inside each asks the model its scripted turn, a purple LLM step, and writes one number into a shared list valued state key. Same code, different payload, independent runs. Now the fan in. The workers don't overwrite each other. The state key is a reducer that appends. 5 amber bars finishing at different moments, all draining into one blue node. Reduce wakes up only after every worker is done, reads the appended list and sums it. One value out. And here's why it still reproduces. Concurrency usually breaks determinism. Thread order, timing, races. But the payloads are a fixed seeded list, and every model turn is replayed in strict order from the script. The graph topology is fixed, so the trace doesn't care which worker finished first. Run it twice, get the same trace to the digit. The program. We import the harness, build a state graph with 3 nodes, split, work, reduce, and a state where the results key uses an append reducer. So parallel writes accumulate instead of clobbering. Split is the fan out. It reads the seeded list of 5 chunks and returns a list of send, work, chunk, C, I, 1 per item. Returning a list of send is how you tell LangGraph. Invoke work once for each of these concurrently. Work is one worker. It pulls its chunk, asks the scripted LLM for this index's can turn, a number as text, parses it and returns the results, value. The reducer appends that one element list into the shared key. Reduces the fan in. LangGraph runs it only once. After all 5 workers commit, it reads the full results list, sums it and records the total. Every step is logged to one trace. Run it. The terminal prints the fan out width, each worker's passed value in payload order, the appended list at the reduce node, and the final sum. 5 workers, values from the script, 1 total. The figure is a fan out, fan in Gantt drawn from the trace. 5 amber worker bars staggered across the lane, then a blue reduce bar that starts only after the last worker ends. The parallel work visibly collapsing into one node, headlined with the sum. So parallelism in an agent graph isn't a new mental model, it's MapReduce, and send is the map. Seed the inputs and script the turns, and even concurrent runs reproduce exactly. Next, we stop hand-tuning prompts and let an optimizer search them for us, the optimizer paradigm.